to represent them. And guys, when we're working with the Argand plane, we don't work with the X and Y axis, we work with the real and imaginary axis. Alright, you see? That is what the RE stands for. We did that last term. And the IM stands for imaginary. So you need to remember X axis is real and Y axis is imaginary. Okay? Please remember that. I'm going to show you how we will actually plot this number, that number there, and how we will plot that on the Argand plane. Okay, you can just draw your axes, please. I almost said y-axis. My imaginary axis is going up to, I'm going up to 2 there, but actually just above 2. And then the real axis doesn't really have to go very far. Mine goes up to just past 3, so it doesn't really matter. I mean, if you want to, sure. Feel free. Now, guys, we all know that when we have a complex number, right? Hopefully, we all know. I'm saying we all know, but maybe we've forgotten. We haven't looked at these things quite a while. A complex number consists of a real part and an imaginary part. All right. So last term, I think it was in your class, maybe even in your test, if I gave you a number Z like that, I can ask you, what is the real part of Z? Right? What is the real part of that complex number? It is 1. What is the imaginary part of Z? 2. So guys, when we are plotting this value, this number, onto the Argand plane, we're going to plot it as a point. Right? That's what we do on the Cartesian plane, right? We plot points. This point has to have a real value of 1. So when we're looking at the real axis, it needs to be in line with 1 on the real axis. And it has to have an imaginary value of 2. So on the imaginary axis, it has to be in line with 2. So that is where you are going to plot data. In line with 1 on your real axis and 2 on your imaginary axis. You can write the coordinates of this point as 1, 2. Like we normally would with an X and Y coordinate. It's now just a real and imaginary coordinate. Okay. The X coordinate is the real value and the Y coordinate is the imaginary value. Okay, and that's basically what you need to do is they ask you to plot the complex number on the Argand plane. You need to identify what the real part of that number is. That goes on your real axis, your x-axis. And you need to identify what the imaginary part is. That goes on the y-axis, on the imaginary axis. Now guys, from this, you can draw a straight line connected to the origin. So please do that. Another way in which we can represent complex numbers, not necessarily writing it in this form or by using these coordinates, is what we call polar coordinates. All right, so more terminology, and they are big words. Don't stress, I'm going to explain to you what each of those words actually mean. Right, we can also represent complex numbers using polar coordinates, and that is when we are using R and theta as our coordinates. I'll explain to you now what that means. We're not actually going to look at it again, but you have to do the text along all the way through. No, complex numbers is never done. Another. My favorite, actually, my favorite is an argument. To be quite honest, it is.
Well, I mean,
Argument.
but
Yes.
well, I love it. What do you say? All the time.
Then when you are then like well done.
You can argue.
Yeah, you can hold, you can argue. Or just if you enjoy confrontation.
Oh, wonderful. Wait till I come over. All right, guys. So now, are we fine if we copy that down?
What's
Yeah.
the nine or?
You'll see now. It's time hard.
Modulus.
All right, guys, we are going to put R on that line. R, the modulus, that is the positive distance, right? Positive distance from the origin to the point. Okay, we just see if that's the exact wording that you use. Positive distance from the origin. Okay, you can write that there. Positive distance from the origin. And we'll talk about how we're going to find that value. And then theta is an angle, right? We saw that in class. Theta is actually this angle over here. Theta is going to be that angle. That is we call it the angle of inclination. We do work with that next year in grade 11 quite a bit. For now, I'll just explain to you what that is. That's the angle of inclination of the line, and angle of inclination is always from the positive, and I'm going to say axis, real axis. It's on the positive side of the real axis. So the angle of inclination of the line measured from the positive So that as soon as you actually connect the point, right, the complex number that's on the origin plane to your origin, we can then start talking about the modulus, which is the distance from the origin to that point, and the argument, right, which is the angle between the lines that you draw in there. Oh, sorry, let me just move this down, which is the angle between the line and the positive real axis. Wait, what? That is the argument, that angle there between your line and your positive real axis. And guys, how are we going to find those values? Pythagoras, yes. And then also, what else? Trig, there we go. Okay, so let's draw in, let's draw in our right angle triangle here. You see why we had to do trig before we did that? Okay, let's draw in our right angle triangle. Mine is a bit small. I can't really fit in my 90-degree angle there. I'm going to put it on the outside.
Mine's poor. And then go on to mine.
No idea. I'm struggling now. What's happening now?
Nothing is happening, guys. No, sorry, the triangle is a bit narrow. Sorry, guys, I should
That's not your fault, man. Mine is the real fault.
Remember, look, it's like,
That's fine.
it's irritating. And I ran out of tools.
It's okay, guys, we'll be all right. I promise. Okay, thank you, thank you. It's so confused.
Sorry, Dad.
What is this distance here? What is the length of this side of our triangle? Are we focused, please? 1 unit. What is the length of that side? 2 units. Please calculate R for this one. Just do it here on the side somewhere. R is like hypotenuse of that triangle, right? This length of this side is 1 unit. The length of that side is 2 units. To find the hypotenuse, the length of R, the modulus, you're gonna have to use Python, okay? This is not. I said, okay, wait. Guys, you can just squeeze it in wherever. If you don't have space, don't stress. Just do it like on the side or somewhere.
Can we leave it in circle?
Yeah. Because you have to square root. Okay, there we go. That's what I got. It's not. We agree.
Yeah.
Guys, to be honest, in AP, I don't see them actually taking the command to run around Pythagoras there, but in 4 they will, alright? So whenever you're working with a right angle triangle in any kind of plane, in 4 we'll be working in Cartesian plane, and in 4 they are very strict on reading. Okay, so let's keep practicing it everywhere so that we don't forget. Whenever we're using Pythagoras, it's actually right. Yes. Can't remember the reason. Yeah, even though it's right. Can't use it right. What do you mean?
Surely, man.
Like, because, exactly. I mean, you can try to.
I read found.
It's a found.
My brain just froze.
Josh, I'm gonna tell you,
Honestly, I'm not that embarrassed. Like everyone's done.
I've done it to Matt. Yeah.
Alright, thank you. Okay, guys, what about theta?
Well, now we can.
Find theta.
Go searching.
No,
Okay.
it's be serious.
Opposite of the
Okay,
hypotenuse.
can I learn something? Theta is the angle here. We have opposite and we have adjacent. Which trig ratio works with opposite and adjacent? Opposite and adjacent. Yeah,
I was thinking of opposite on hypotenuse.
Everybody else thinks the sign on the back, like this cat.
Well, you can also use sign.
You could, yes, you use your root 5, absolutely. Okay, let's go, guys.
Change.
You can use tan then to find theta, or if you already have your value for R for your modulus, you can also use sine if you want to do 2 over root 5. You can use cos if you want to do 1 over root 5. It's totally up to you. All right. And now you just have to do shift tan of 2 to get your angle. Do that please on your calculator. See what you get. Sorry guys, I wasn't great on my space slide here.
Oh no, man, it's almost like I have to extend your pain.
There we go. That is the value of theta.
Yep.
Okay. Where do I get it? Okay, then, like, provide one like this.
Really get the white one.
All right. Guys, I would like you please to do this example on your own. Okay, I'm going back up quickly, so everyone can write this down. Yeah. Quickly.
What else do you have?
Someone's had a long
Pause.
Sorry, my fault.
Okay, okay, oh, sorry, guys. Okay, there we go. Example one, you're doing this on your own, please. So I've given you the complex number, I'm just calling it Z, remember you can call it whatever, okay, we're just going with Z. 2 plus I would like you to represent this number in the Argand plane, and then express the number in polar coordinates.
Polar coordinates is the line.
Polar coordinates is the R and the theta, and guys, then you just write it in brackets, right? You put your R value first and then your theta value. Sorry, I didn't actually do it for the previous one. For the previous one, if you just want to go back, I'm just going to go back up quickly for 1 second. Sorry. If we just do this here, Z here is going to be in polar coordinates root 5 and 63,43 degrees.
Okay.
So that's your R value and that's your theta value. So those are the actual polar coordinates for root.
Oh, yeah.
All right. So guys, you only do this if they ask for the polar coordinates. All right. Otherwise, you just need to answer the question that's asked. You'll see. They're going to do another example now where it's the other way around. Okay. Let's do that now for this example. Example 1. Technically, example 2 because we have just done an example, but this is the first proper one that you're doing on your own. Now I'll give you a few minutes to do that one. Yeah, you can write it down and do it.
No, we don't have to write the read.
You do? When you're drawing your axes, yeah.
Oh,
Just like you would. Oh, you mean the actual like read Z and M
no, like you have to write it in the read.
on your axis?
Yes.
Yeah.
And that's example, example. That's it's calculate feet. Yeah, it's okay.
Yes. And calculated all.
Is the will theta be the inside? Like the one closest to the in. To this.
So you draw your right angle triangle to the real axis. And then theta is an angle inside the triangle. The acute angle. Goes from the real axis up to the line.
And the triangle is like that.
Yes. But the point is at the origin.
And that. Real axis and the. I get that, but it's in the angle that's close to the origin.
Yeah, so it's always coming from the real axis. It's always going up from the real axis.
Yeah, but it's.
Are you guys done? Oh, yeah, that's.
Oh, this is your. Okay, here we go.
Okay. So you guys
I don't know where.
don't like it down there.
Never saw.
Can I go? Don't look, just don't look.
Never.
Okay, don't look at the last napkin. There we go. Okay, guys, you can look at my diagram. Bring it 5 points. So there. Right, there goes the number 2 plus 1i. 2 plus I, 2 plus 1i. So the real value is 2, and and the imaginary value, or part rather, was 1. Alright, so we have the point 2, 1. Then you plug your point, you draw your line in, to ask for polar coordinates, you do have to show that. Okay, you need to show your right angle triangle so that you can use straight and Pythagoras to calculate those. So your R value, your modulus, okay, again we use Pythagoras, we'll just get the same answer for that because we have the same 2 sides. Okay, it's just the other way around on the previous question. But then again, so you can decide, do you want to use tan or sine or cos, any of, or yeah, all 3 of them would have worked. You would have gotten the same answer. Alright, so tan theta, I said is opposite over adjacent, 1/2. Yes, so you do shift tan and you get your angle. Right, please conclude with this line. You need to write that Z is equal to your R value and then your theta value.
So then Z is equal to the R value and then is that the polar?
Those are
So you always start with the R and then.
yes, so in the order of the, yeah, so it's like an X and a Y, the R is always coming Yes, I don't even know. I would probably give 1 for this. 2, 3, 4, 5. Yeah. Oh, right. So here, there's another example, guys. Oh, all right, thank you. Thank you. Great hands. Great hands. Great hands. Can we calm down, please? Can we focus on the word? All right, the complex numbers, they, guys, now I'm giving you the polar coordinates. So just in case you can't read that, that is root 13 and 56,31. Express the number in the form z equals a plus bi. So you need to go the other way around, guys. In the previous example, I gave you z equals a plus bi, right? I told you what the real part and the imaginary part was by giving you the complex number in its normal notation. Then you have to use that to draw your triangle and then calculate your polar coordinates. Now the polar coordinates are given. You have to now work backwards to get your a and your b value. Right, do we know what an angle of 56,31 degrees looks like? It's in the first quadrant, hey? It's an acute angle. Remember what we did was it in 4 on Friday when we drew the trig on the Cartesian plane thing when we spoke about our quadrant? 0 degrees, 90 degrees, all right? So an angle of 56 degrees is somewhere in the first quadrant. So you can actually draw your Cartesian plane, Argand plane, all right? Let me show you. You can have your, now, I mean, it's not going to be to scale. You don't have to try and draw it to scale. Don't worry about that. Okay, you have your real axis. You have your imaginary axis. You have your origin there. 56,31 degrees. People kind of guess where that is, all right? If you want to guess where like a 60-degree angle is, 56 will be just below. It really doesn't matter. You can literally just draw any angle that you want. All right, you can put that Z point there, connected to the, oh, here we go again, connected to the origin. Okay.
You can just put the date in.
As long as it's in the first quadrant, okay, because it is an acute angle. You can draw in your right angle triangle from there. And just like in four, guys, we always attach the right angle triangle to the real axis, okay, which is like the x-axis. Now, if they have told us that these are our polar coordinates, the first value, the modulus, that is the length of this line, the distance between the point and the origin, right? So they've given us that length. 56,31, they've given us this angle, guys. Let me just zoom in so I can put it in there. 56,31 degrees. They're looking for this, hey? They want us to write Z equals A plus BI. They could use different methods, guys. It's not always going to be A and B necessarily. So let's quickly think. What does A represent here? The real part of this number. So this distance, hey, the length of that side of the triangle, the real side, that is going to be A. B, yes, B is the imaginary part of this number, right? So the imaginary length of this triangle, that is going to be B. Have we done this in trig, in core, right? We have an angle. If we're looking for A, that is the adjacent side. We have the hypotenuse. Which trig ratio works with adjacent and hypotenuse? Cos. Okay, so cos of 56,31 degrees is equal to A over root 13. What does I do with that root 13 to get A on its own? multiply it out, right? So A is going to be root 13 times cos of 56,31 degrees. You can type that into the calculator.
And we only do the shift when it's been
Defining the answer. Right, I'm getting 1,999, a whole bunch of nines.
Yeah.
Guys, something to just be aware of. If you're typing in root 13, let me just show you root 13. You have to press the arrow button to get out from under the square root. Okay, I'm worried that some of you are just typing 13 and then cos 56. It's the square root of 13 multiplied by cos 56,31 on the outside. Okay, this cos is not in the square root. Just be aware of that. That is equal to 1,9. So we agree that we can round that to 2. Okay, so A is just 2 in this case. Now we can calculate B in a similar way. Which trig ratio am I going to use now? If we're looking at this angle, B is opposite over hypotenuse. You could use adjacent now if you wanted to, because we know what A is. We know that it's 2. All right, but let's work with sine. So sine of 56,31 degrees is equal to B over root 13. So then to get B on its own, you must do the same thing. You must multiply root 13 by sine of 56,31 degrees. Let's see what that gives us. 3. Okay, it's 3 comma and then a bunch of zeros. Therefore, what is Z? Z is, remember, A plus BI, so 2 plus 3I. Okay, so you see why we had to do some more trade, because before we could actually do this.
So, you can write in the graph, what we have to do.
It depends on what they're given you. It depends on the question, yeah. Usually you use this diagram as a way of calculating either polar coordinates or
Have to have both dead one and
no, you actually just have to pull those values in on the picture.
so you don't have
I'm sorry, that's not what I wanted to do.
you don't even have dead
Maybe put the Z next to the point just to show that that point is Z. But you don't actually have to write that.
so you have to have 2 1. So here you have to have
I would put that in, it's just like later in the point. But guys, yeah, to be honest, I'm not entirely sure how they're replaced the finals. I'll have to go look at some final papers. It's a relatively new concept. Thank you. Yeah, I'll take a look. I'll take a look and I'll see how they actually take this. Okay, I want you to practice some of this on your own, please. So in your textbooks, exercise 3.3 on page 39. Sorry, that's off screen. I want you to do number 1 and number 2, A and C. There is something else that we first need to do in core, in trade, when we're working in the other projects before we can do the other questions in number 2. So we will come back to that. But this is what you are doing now, please. Get going, get going.